The topic is Introduction to Variables, Algebraic Expressions, and Equations. The objectives in this topic are evaluate algebraic expressions given replacement values, identify solutions of equations, and translate phrases into variable expressions. A combination of operations on letters, variables, and numbers is called an algebraic expression. So some examples of algebraic expressions would be 5 plus x, 6 times y, 3 times y minus 4 plus x. Adding, subtracting, multiplying, or dividing numbers and letters gives us algebraic expressions. Just as a reminder, 4x means 4 times x, and x times y means x times y. So I guess this isn't a reminder. This must be the first time we're coming across this. We've been used to the dot notation. Remember, I said, get rid of the x, get rid of the x meaning times, because we're going to introduce x meaning something else eventually, and that's now. So 4xx is confusing. We would use 4 dot x. We can take that one step further, get rid of the dot entirely. When we have a number and a letter mashed right up against each other, that means multiply. So 4x means 4 times x. And when we have two letters mashed right up against each other, that means multiply. xy means x times y. So we could rewrite those algebraic expressions 6 times y as 6y, and the 3 times y minus 4 plus x as 3y minus 4 plus x. They would mean the same thing. Replacing a variable, replacing a letter in an expression by a number, and then finding the value of the expression is called evaluating the expression for the variable. So for example, let's evaluate x minus 2 if x is 7. Well, that's telling us to take x and plug it in, take 7 and plug it in for x. X is 7. So instead of x minus 2, we would have 7 minus 2, which is 5. So we've evaluated x minus 2 for x equals 7. It's 5. Let's evaluate y times the quantity x minus 3 for x equals 8 and y equals 4. So again, we're going to make our replacements. X becomes 8, y becomes 4. So instead of y times x minus 3, we have 4 times 8 minus 3. We can then follow the order of operations, parentheses first, 8 minus 3 is 5. Finally, 4 times 5, that's what the parentheses mean, times 4 times 5 is 20. Let's evaluate y plus 6 all divided by x for x equals 6 and y equals 18. Once again, instead of y plus 6 over 18, we're going to have 18 plus 6 over 6. Make our replacements for y and x. Y is 18, x is 6. Order of operations says work on the top and then take care of dividing by the bottom. 18 plus 6 is 24. 24 divided by 6 is 4. (25 minus z cubed plus x). We're evaluating that for z equals 2 and x equals 1. One of the things I want to point out is notice every time we are given values for all the variables in the expression. So since there was a z and an x, we're only able to evaluate if we have a value for z and a value for x, which we do here. Z is 2, x is 1, 25 minus 2 cubed plus 1, order of operations, says take care of the exponent first. 2 cubed is 8. Then order of operations says add and subtract left to right as we come to it. So subtract first, then add. 25 minus 8 is 17, plus 1 is 18. Now, as opposed to an algebraic expression, an equation is something like 5 plus 2 equals 7. It's of the form expression equals expression. Equations have equal signs. They are setting two expressions equal to each other. So there's the equal sign, there's the left side, and there's the right side. A solution for the equation would be a value for the variable that makes the equation true. And finding solutions, finding things that make the equation true, that process is called solving. So first we're going to determine whether things are solutions, and then eventually we're going to move on to solving. Let's determine whether 2 is a solution of the equation 2y plus 1 equals 3. Well, we know how to evaluate these expressions when y equals 2. That's what we're doing here. We're plugging in the 2 everywhere we see a y. We're simplifying the left, we're simplifying the right, and then we're seeing if we get a true statement. So let's replace y with 2. 2y plus 1 becomes 2 times 2 plus 1. We want to know if that's equal to 3. 2 times 2 is 4. 4 plus 1 is 5. 5 is not equal to 3. We get a false statement. Since 5 equals 3 is a false statement, 2 is not a solution of the equation. Just like we had for addition and subtraction and multiplication and division, we have some key words and phrases for the equal sign. Let's review some of our keywords and phrases. Recall that some keywords and phrases for addition were sum, plus, added to, more than, total, and increased by. And remember, those addition words, because we can add in any order, there's no order attached to them. Unlike the subtraction words, where order is going to matter. We have difference, minus, less than, decreased by, less, and subtracted from. And when we say subtracted from, for instance, 7 subtracted from 9, we're starting with 9 and we subtract 7 from that. Back to one where order doesn't matter: multiplication, product, times, of, twice, multiply, double. Then back to order mattering: division, words like quotient, into, per, divide, divided by. And let's keep this pattern going. For the equal sign, order will not matter. If I say 3 equals 1 plus 2, that's the same as saying 1 plus 2 equals 3. So equals, gives, is, was, will be, yields, amounts to, is equal to. Any of those mean we have an equal sign. So let's write as an algebraic expression using x to represent a number. The product of 5 and a number. Product is multiplication. 5 and a number. 5 and x. 5 times x, or 5x. Twice a number, that's multiplication. Twice a number means 2 times a number, or a number times 2. 2 times a number is 2 times x, which is 2x. A number decreased by 3. We're starting with a number, we're starting with x, we're decreasing it by 3, we are subtracting 3. We're subtracting 3 from x minus 3. The opposite of decreasing by is increasing by. A number increased by 2, we're starting with a number, we're starting with x, and we're adding 2, x plus 2. And 4 times a number, 4 times x, 4x. Between that 5x, 2x, and 4x, it's like this multiplying by x is kind of important, huh? The sum of a number and 7. The sum of is addition. A number and 7 would be x and 7. The sum of x and 7 is x plus 7. 3 times the sum of a number and 7. What is the 3 multiplied by? It is multiplied by the sum. The sum of what? A number and 7. So we have x plus 7, and we're multiplying 3 times that sum. That requires parentheses. 3 times the sum of x plus 7. To write 3x plus 7 without parentheses would be wrong. It would be incorrect. That would be 3 times a number plus 7, or the sum of 3 times a number and 7. We wanted 3 times the sum, so we needed the parentheses. Finally, the quotient of a number, the quotient of 5 and a number. Why do I have to correct myself there? Because order matters with division words like quotient. So 5 and a number, the quotient of that would be 5 divided by the number, 5 divided by x. So I can't drive this home enough. Please remember that order is important when subtracting and dividing. Study the order of numbers and variables below. A number decreased by 5 is starting with a number and decreasing it by 5, subtracting 5 from the number. On the other hand, a number subtracted from 5 means we're starting with 5 and we're subtracting x from that. And that is it for this topic.